All right, today we want to talk about equivalent fractions and reducing fractions or expanding fractions. When we expand a fraction, we basically write it using numbers that are bigger than either the original numerator or denominator. Whereas when we reduce a fraction, we write it using smaller numbers. Now, when I think of a fraction such as the one shown here, I see that this one would represent I have 2 out of 3 equal parts. But if I divide this whole square up differently, then I can write this fraction in different ways. If I was to cut this right down the middle here, instead of having 3 equal pieces, I now have 6 supposedly equal pieces. Let's say they're equal pieces. And instead of having 2 out of 3, I now have 4 out of 6. Yet the amount that I have hasn't changed. So if we think of this as a square pizza, I would still have the same amount of pizza, but instead of having 2 out of the 3 pieces, I would have 4 out of the 6 pieces. Now if I cut it again, now I couldn't just cut it like this, because suddenly these 2 of the pieces are much smaller than some of the others. So we have to cut it again this way. And again, assume that those are equal. I meant them to be equal. Now instead of having 3 pieces or 6 pieces, we now have, if we count them up, 12 pieces in total. And if the green represents the amount that I have, I get 8 out of the 12. Now once again, it hasn't changed the amount of pizza I have. It's still the same amount of pizza. Now the question is, how do I move from 2/3 to 4/6 then to 8/12? Well, if I look, what I can do is what I really did originally is I took each of the pieces and cut them into 2 more pieces. So there was originally 3. I cut each of the 3 pieces into 2 equal pieces, making 6 pieces. So these were also cut into 2s. Now when I look at that, I'm multiplying both the top and bottom by 2. Now when I think of 2 over 2, we talk about really you're multiplying by 1. And multiplying by 1 doesn't change a number, because if I take any number and multiply it by 1, I still get that same number. Now if I was to think of this 2/3, what do I do to 2/3 to get 8/12? Well, for each of the 3 original pieces, I would have to cut those into 4 pieces. So I'd have 4 times as many pieces. And I had 2 out of those 4, so I would end up with 8 out of 12. So what we can do is we can multiply the top and bottom by the same number, and that will give us an equivalent fraction. Now I can also work the other way. What would happen, how do I work from 8/12 to get 2/3? Well, if you think of it as instead of cutting into equal pieces but combining the pieces, which I know is hard to do once we cut them, but what do I do to 12 to make it into 3? Well, I divide by 4. And if I divide this one by 4, I get the same number. I get 2. Now again, dividing by 4 over 4, we say that's the same as dividing by 1. And dividing by 1 leaves us with the same number. Now, it doesn't only work with 2/3, it works with any fraction we want to consider. If we look at this, this represents, there's 4 pieces, and I have 3 out of the 4. So we have 3/4. Now if I multiply the top and bottom by 2, I'll get 6/8. Now what does that look like? Well, that would mean I would take each of these pieces and cut them into 2 pieces. And I have 6 out of the 8. Now instead of doing it that way, I could say, well, still start with I have 3 out of the 4 pieces. But let's say I was to cut each of those pieces into 3 equal pieces. So instead of having 4 pieces, I would get 12, and I have 9 out of the 12. And again, if I was to cut this, let's see if I can cut it equal. Well, not bad, roughly equal. You see that now the square is cut into 12 pieces, and instead of having 3 of them, I have 9 out of the 12. So again, that's an equivalent fraction. Here, this fraction would, well, if you count the pieces, there are 5 pieces, and I have 2 of the 5. And let's say I was to cut each of those into 4 pieces. So instead of having 5 pieces in total, I would have 20 pieces in total, and I get 2 out of those 5 original pieces. Since I cut each of the pieces into 4, 2 times 4, I will get now 8 out of the 20 pieces. So let's cut these. Okay. If you were to count each of the pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. There's now 20 pieces, and I get, out of that 20, I get 8. So visually, that's what I think of when I'm working with fractions. Now if we were to move on, that's okay. Yeah. If we were to move on to the next one, you see that I have 1/4, and one of the questions we ask you is 1/4 is equal to what over 16? Now again, what I think about is I think, okay, so I've cut something into 4 equal pieces, but now I want to cut it into 16. So each of those 4 pieces, I have to cut into 4 additional pieces. So I'm going to multiply this by 4. And if we multiply the bottom by 4, we have to multiply the top by 4. So I'm going to get 4 out of the 16. And to just show you what that would look like, each of those pieces are cut into 2 more, 3 more, and now 4 more. And you see I've got 16 pieces in total, and I got 4 out of 16. If we're to look at the next question here, instead of drawing it out visually, I'm just going to think about it. I have something that's cut into 7 pieces, and I have 2 of them. I want it to be cut into 42. So the question is, what do I have to do with each of those 7 pieces to make them into 42? Well, 7 times what gives me 42? Now, if you're not sure, we would use division, but if we remember our times table, 7 times 6 is 42. So 2 times 6 would be 12. So 12 over 42 is equivalent to 2 over 7. Now that's called expanding a fraction. To reduce a fraction, we want to go the other way. We want to turn it into a fraction with smaller numbers. And there's 2 ways we can do this. The one way that's really common is to look for a number that will divide into both the top and bottom. So if I look at 28 and 70, I know that both of those are even, so 2 is going to divide into them. So I start out and I say, okay, I'm going to divide this by 2 and divide this by 2. And I'm going to get 14, and on the bottom, I'm going to get 35. Now again, if we need to, we can use long division to do either of those. Now, I look at 14, and it's even, but 35 is not even. So I can't use 2 again. Now, what's another factor of 14? Well, 2 times what? 2 times 7. Now, does 7 go into 35? And sure enough, it does. So I can divide both of those by 7, and I will get 2 over 5. Now, if I look at 2, the only factor of 2 is 2 and 1, so it's a prime number. So is 5 a prime number. So we've reduced this fraction as completely as we can. This process is called repeated division. Now, as it turns out, every fraction, when we write a fraction in final form, we must reduce it. We always, always, always reduce it. So that's one method, is repeated division. The other method that we show you in this unit is what we call using a prime factorization, where we go back to something that we learned in Unit 2, and we say, okay, 28, what goes into 28? Well, 2 does, and that leaves me 14. And what else goes into 14? Well, 2 goes again, and that leaves me a 7. Well, 7's prime, so it's 7 times 1. So the factors of 28 are 2 times 2 times 7. Okay? And we do exactly the same process for 70. Now, what goes into 70? Well, it ends in 0, so 2 must go in there, and that leaves me with 35. Now, since that ends in a 5, I know 5 goes in there. And if we think about the hands on the clock, 35, that's 7. And 7 is prime, so 7 times 1. So we think of 70 as 2 times 5 times 7. And now when we look at the original factor, we have it in terms, or the original fraction, we have it in terms of its factors. And we can divide out any factor that appears on the top and the bottom. So if I look, 2 divided, there's a 2 on the top and a 2 on the bottom. Now I realize there's 2 2's on the top, but I only need 1. There's 1 on the top and 1 on the bottom, so I can divide those out, because 2 divided by 2 is 1. I can divide this and it becomes a 1, and I can divide this and it becomes a 1. Now if I continue to look at the top, I have another 2, but there's not another 2 on the bottom, so I've got to leave that 2. If I keep looking, I have a 7 on the top and a 7 on the bottom, so that 7 will divide out and give me a 1. That 5 will divide out and give me a 1. So now if I multiply that out, 1 times 2 times 1 is 2, and 1 times 5 times 1 is 5. Now, as long as we factored it into its primes, this method will always work.